All right, let's get right into it. Today, we're not talking about certification basics. Nope. We are going way beyond the console to talk about the reality of running actual applications on AWS, what it takes to build systems that don't just work, but can actually survive when things inevitably go wrong. So let's start with a scenario that every engineer absolutely dreads. It's 3 a.m. and your application is down. But here's the thing, it's not down because a server crashed in a way you might expect. It's down because of a fundamental and super common misunderstanding of what the cloud actually is. The problem isn't your code, it's your architecture. To really get to the bottom of this failure, we have to peel back that shiny API layer. We've got to stop thinking of AWS as some kind of magical, invisible thing in the sky and start thinking about what it really is: a massive, global network of physical buildings packed with physical computers. Yeah, it's so easy to forget this, right? Our applications, our code, it's all running on real hardware in real buildings. And just like any building, they can lose power, they can flood, or a network cable can get cut. So the real question becomes, how in the world does AWS organize all this physical stuff to keep our apps from going down with it? And that question brings us to probably the most critical concepts for building systems that can take a punch: the difference between regions and availability zones. Seriously, understanding this is the key to surviving that 3 a.m. wake-up call. So a region, think of it as a specific, separate area on a map. You might pick the North Virginia region to be close to your users on the East Coast, or maybe a region in Europe because you have to keep your data there for compliance reasons. The key thing to remember is that these regions are totally isolated from each other. Now, an availability zone, or an AZ, this is where it gets really interesting. An AZ isn't just a part of a data center, it's one or more entirely separate data centers. We're talking different buildings on different floodplains with their own power grids. They're designed from the ground up to be independent failure domains, all within that single geographic region. And this table just lays it all out perfectly. A region gives you that big geographic footprint, but an AZ, that gives you fault isolation inside that footprint. And you gotta look at that latency number. We're talking single-digit milliseconds between AZs. That right there, that's the secret sauce. That's what makes true, real-time, high availability even possible. Okay, so we have this knowledge now. How do we use it to fix our broken application from that 3 a.m. nightmare? Well, we're going to re-architect it for high availability, right inside a single region. Let's build it up, step by step.
First things first, we stop sending users directly to a single server. Instead, we put an elastic load balancer, an ELB, right at the front door. Its entire job is to be an intelligent traffic cop, directing all the incoming requests to healthy servers.
Next, we take our web servers, our EC2 instances, and we put them inside what's called an auto-scaling group. And we configure that group to span at least 2 different availability zones. So now, if an entire data center goes dark, the load balancer just notices, and it stops sending traffic there. Your users, they have no idea anything even happened. And this is the really crucial part for our data. We set up our RDS database to be multi-AZ. What this does is create a perfect hot standby replica in a second availability zone. And because of that super low latency we talked about, the data is copied over synchronously. If the main database or its whole AZ goes down, RDS just automatically promotes the standby to be the new primary. It usually takes less than a minute. So with just those 3 steps, we've basically established the multi-AZ principle. This is a huge shift from how things used to be done on-prem. We've gotten rid of single points of failure by spreading everything across separate data centers, and we're letting AWS managed services handle all the automatic failover stuff for us. By the way, if you're finding this deep dive into production architecture useful, we upload one daily to DevOps Corner. Take a second to like this explainer and subscribe so you don't miss the next one. Okay, so we've solved for an AZ failure. Our app can now survive a whole data center going offline. Pretty cool. But what's the next biggest thing that could fail? The entire region. As of right now, AWS operates in 34 different regions all over the world, and that number's pretty much always going up. This crazy scale isn't just for show. It's the foundation for true disaster recovery and for building apps that are super fast for users anywhere on the planet. Look, it's rare, for sure, but regional outages have happened. A huge storm, a massive network problem. If your business absolutely cannot afford to be down, then you need a plan that can survive an entire geographic area disappearing from the internet. And this is where multi-region architecture comes in.
One of the most common ways to do this is with Route 53, which is Amazon's global DNS service. So what you do is you deploy a complete independent copy of your application in a second region, let's say Oregon. Then you use Route 53 health checks to keep an eye on your main region. If it becomes unhealthy, Route 53 just automatically starts sending all of your users to the healthy stack over in Oregon. Now, this level of resilience, it's incredibly powerful, but it absolutely comes with some major trade-offs. And this is kind of the whole story of the cloud, right? It's why startups can scale globally overnight, but it's also how your bills and the overall complexity can just spiral out of control. So the big takeaway here is this. AWS gives you all these amazing building blocks for scale and reliability. But for every extra 9 of availability you want to add, you're also adding more cost and more complexity. You're not just paying for the servers you use, you're paying for all the redundant stuff that keeps it running. And yeah, that includes things like paying to move data between regions. It's a constant balancing act between being resilient, being fast, and, not going broke. When you boil it all down, this entire global network, all this complexity with load balancers and databases and regions, it all exists for one fundamental reason: to give you a reliable place to run the most basic unit of the cloud. And that, of course, is the virtual server. So, we've covered the macro view, the big map of AWS. In our next explainer, we're going to zoom all the way into the micro. We'll break down that virtual machine itself, the EC2 instance, and explore how to pick one, how to configure it, and how to actually manage it in a real production environment. Thanks for joining me.